Okay, yesterday we learned a big topic, which was the associative and the commutative property of addition and multiplication. And today we're going to dive deeper into the third major property, which is distributive. And the distributive is actually both. And I just want to use this problem to demonstrate that you've actually been using it every time you combine like terms, which is something you've been doing since 8th grade. So if we look at 3x and 5x, these are we combine those, and most people are pretty solid at this point, knowing that 3x and 5x is 8x. But there's actually kind of the use of this distributive property going on, and the commutative property, all in one, which makes this possible. So this is a nice little visual to show that the distributive property is. Well, maybe we should talk about that first. The distributive property is when we're taking things like a number or an expression, and we're multiplying them together. So this is a picture for, just like we talked yesterday, 3 being multiplied by x plus 2. So this distance is 3, this is x, this is 2, so together x plus 2. And the distributive just tells us that this 3 is going to get multiplied by both of these dimensions to create this area. So 3 times x is 3x. 3 times 2 is 6. So together that's 3x plus 6. Okay, so we did this a little bit yesterday, so this is kind of revisiting things. So these two are equivalent expressions, and that's an example of the distributive property. So going back to, like I said, this example of 3x and 5x, this is really an example of something like this, that it's x being multiplied by both 3 and 5. So x times 3 plus 5, well, what's 3 plus 5? That's 8. X being multiplied by 8. And then, of course, we know x times 8, 8 times x, same thing. That would be our commutative property in action. So like I said, this is a nice example of the distributive property that also makes this happen. Now, do you need to do this every time? Absolutely not. If you know that 3x and 5x is 8x, just leave it. But that's just an example of where this distributive property is also used elsewhere. And then same thing, like this is a huge concept that we're going to use quite a bit this year, that this idea of going from expression on the left to expression on the right, that's called distributing. And that's what we're going to cover a lot first semester. And second semester, we'll revisit this distributive property. Some people call it undistributing, or reverse distribution, but the proper word for that is actually called factoring. And that will be another big topic for our discussions this semester. So here we go. This is kind of a really common mistake that we've seen, and it's a distributive property mistake. And so Leela is convinced that a plus b squared is a squared plus b squared. Is she right? And pictures are really, really helpful. Just remember that these area models that we're going to use all year long is going to help us figure this out. So understand that squaring, remember, means multiplying by itself. So a plus b squared is actually a plus b times a plus b. And an area model to represent this situation would have to be something like this: a plus b getting multiplied by a plus b. And now we can figure out what this equals. So our dimensions here, a times a, that's a squared. A times b is ab. And remember, when we write ab, we mean a times b. This area would be b times a, which is ba, or again, our commutative property tells us that's also ab. And then b times b is b squared. Looking for like terms, we have a few. So we have a squared doesn't have any like terms, so that's our a squared. So there's that part of the prediction. We have a b squared, so there's that part of the prediction. But we're missing this third and fourth term. In fact, those are like terms. AB plus AB, really that's like 1AB plus 1AB is 2AB. And that's what's missing. So we could say that Leela is definitely incorrect, a really common mistake. If you actually replace A and B with numbers, it's even more clear. So if I say 3 plus 4 squared is equal to 3 squared plus 4 squared, 3 plus 4 is 7, so 7 squared is 49. Okay, but 3 squared is 9, 4 squared is 16, and that's definitely not 49. So very, very clear when it's numbers, but now we just proved why it's not true with variables.